All right, so we're just recording as of now. So basically, yeah, the 18th of April, and we're doing module 6, which is going to be our slabs and footings. And sorry, my mistake, guys, to the ones last week when I said we're going to be doing subfloor. I got my units all mixed up, and then when I went on today to set up the webinar, I realised Maxine had put on all the stuff we need for module 6. So apologies if you thought you were coming and doing subfloor. That'll be next week. So tonight we'll be doing basically our slabs and footings. But what I thought I'd cover with you, and I think Luke's just joined us. Luke, is this your first time, mate, Luke? I don't think Luke's got on microphone by the look of that. What I might do, guys, is just mute everybody for a second. So yeah, Luke looks like I don't think I've seen Luke's name on here before, and Jeffrey, but Jeffrey's basically cut out for a little bit. So if you're there, Luke, I've got a feeling you don't have a microphone, but you can probably type to me, mate. So if this is your first time and you've got any questions, by all means, if you can talk, just talk to me. And otherwise, mate, just type them in the box and I can help you out from there. So, yeah, what I thought we'd do, guys, is just start, and I'll forward this email on. And basically, this is Michael who went through last week for his DBU. And g'day, Dean. How you doing? I think it might be Dean's first time as well. Is it your first time as well, Dean? Might be. All right, well, I'll keep going on and we can talk about that a little bit later. All right, so, yeah, what it is, actually, Michael, I didn't know personally. It was just, oh, you didn't receive it, Valerie? Okay, mate, I'll send it over. Basically, yeah, Michael, I didn't know him from a face-to-face class. It was just he was doing the online as a bit of a top-up. So I didn't know too much about his background. He was going for his DBU, and I'm presuming by reading this that he must have had a diploma. So he just said that he thought he'd send this email so we can forward it on to you other guys. So he had Simon Rowe, and this was as of last Wednesday, and he only had to take in 3 jobs, so he must have been on the old application. So basically, he went in with his 3 jobs, and he said, I'll see if I can make this a little bit bigger for you guys, because probably it might be a bit small on your computer. No, I can't make it bigger. So I'll just read it to you. He said he only had some of the application with him, so he recommends that when you go in, you do actually take in your whole application, because basically when he was questioned on stuff, he didn't have a copy there to read out, and he had to borrow the assessor's copy. So he said he recommends that you always take in your own application. And he said he questioned him on soil, slabs, frame, defects, how he set up the site, his sewer points, his asset protection on the neighbouring properties. Sorry, his asset protection and also protection of neighbouring properties, and then spoke to him about his estimating and organising his other trades. And then he gave, so basically they went through all that, and then he gave him some drawings to do, and he had an hour to do it. So basically from there, the plan was a double-storey house. We had to work out his timber spans and complete the frame, which included top and bottom plates, studs, lintels and jam studs. And he said the top and bottom plates, when he comped them up, they were 390 by 45. And he said he'd obviously never done that or seen it, but he wrote it down because that's what the book had, and it was correct. And he said the second one, the plan he had was a double-storey house. And he had, and there was basically a red circle with possible faults. And then he had to access the building code and the standards to actually say whether they were faults or not. Yeah, and I will just, got a few guys saying there's a fair bit of feedback coming through, guys. So we'll just mute everybody. So if you've got any questions, just type them in the box to me. All right. So yeah, and he said basically with his time frame, he still had 2 questions left to do, and he ran out of time. But then, yeah, basically Simon just guided him through the last 2. And he said whilst he wrote down, he actually called 3 references, not his 2, and yeah, just one from a supervisor from his company. So I'll send all that over. And basically what happened was at the end of it, they just basically had a bit of a chat, and he spoke to him about his other work history and said, you probably should go for your commercial as well, but said he was basically going to recommend him for his license to the Building Practitioners Board. So what I'll do, guys, I'll basically No, Super, they wouldn't be, and I'll talk to you about that a little bit later on as well. So Super's just asked me how does that differentiate from his DBM. Yeah, well, I'll cover that at the end, mate, and I'll talk about, because Ben's going for his DBM, I think, this week or next week. So when he goes through, Ben's someone who's on the online class as well, and I'm sure Ben will be happy to share his experience with you about what he's asked to give you a bit of a heads up too, Super. All right, so yeah, he was basically recommended, and as I keep saying to you guys, the beauty of it is, you know, that all these people who are doing the same course you guys are doing are all passing. So I know there's a guy I train face to face who's going in on Thursday. He told me today that he's nervous as all hell. I know it's easy for me to say because I'm not going to be there on Thursday getting interviewed, but yeah, the guys are passing, and so if you've done basically the work and you've studied up on your jobs you've submitted, then you go in very confident. Because Michael, on this case here, he was nervous as all hell, he told me. But yeah, same thing. He went in and basically he was basically recommended. All right, so we'll forward that on to everybody. And so what I'll do now, guys, we're going to start our module 6. And so I don't know if you guys, depends on how old your study buddy, if that's what you call the folder you've been given from builder registration, depending on how old your folder is, that quite often they have this quick reference basically at the front of each module. So if you haven't got it, I will forward this over in an email later on as well to everybody. And this is just a quick reference. So I use it as a bit of a guide too, so you guys know what we're going to be doing tonight. But then also for yourself too, when you're doing a bit of study and you go, geez, where did I find that information on the bearing capacity of soils? Then it's basically listed on here that it's in Australian Standard 2870 and it's clause 2.4.5. So this here, basically what we're going to be covering, we'll do soil classifications, bearing capacity, reinforcement, basically our trench mesh, our square mesh, how much it's got to be lapped, what sizes that we need. Then we'll be interpreting basically the different tables that we're going to use. And with those tables, we'll then be using basically strip footings. We'll be doing waffle rafts and also our stiffened raft. And that's one thing I think we want to try and get used to, guys, is using probably the proper terminology as per the standards. And I'm a shocker for it. I always just call them waffle pods. And so if you hear me relate to a waffle pod, it means you know, a waffle raft. And same, and I just normally call the raft slab, like the stiffened raft, just a raft slab. So I'll try my hardest to call it a stiffened raft tonight. But I think if we get used to calling it by its proper name, then we should be able to navigate our way around through the Australian Standard 2870 a little bit easier. And so from there, we'll cover, you know, what a deep beam is, yeah, a bit about pads and stumps, also our concrete, you know, what's the minimum MPA, what's the minimum size of our aggregate, and what's the minimum slump. And yeah, so you can see there, edge rebates. Some of these ones here is basically there's a lot of the stuff you'll definitely get in your multiple choice. You know, if you've got to do your multiple choice. And then when we do our drawings, we'll be going about the continuity of our beams and what size those beams are and the spacings and so on. So that's really what tonight's going to cover. And so we'll go through to normal to around, you know, sort of 7:15, 7:30, have a bit of a break. And for those guys who have actually done this before, when we set the activities, what we can do is I'll just change basically what the soil classification is. So if the original one was in your book, say a class M, we might then change it to a class P just to try and change it up a little bit for you guys so you can still be involved in it as well. So what I thought we would do, guys, is just start with the soil classification. And it tells us here that it's on, in our Australian Standard, basically in the chapter 2 and then clause 1.2. So what I'll do, I'll just bring that up, and I just like to cover what the different classifications are and also what they mean. So bear with me 1 second and I'll just open that up. Let's get rid of that. I'll just make this fractionally smaller. 1 second. All right, so it's on basically, if you've got the same versions as me, which I'm sure you all do, it's on page 17. I've gone way too far. Got to be keen. All right, so this here, I might shrink that a little bit more. So this here, as you can see, it says site classification based on soil reactivity. So this is when we get our, if you're not too sure how it works, guys, and I have all got you on mute as well because of the feedback. So if you've got any questions, just type them in. I'll take it off mute a bit later and see how we go. But yeah, I'd hate for you to be talking to me and basically I can't hear you because I got it on mute because of all the feedback. So basically the way this works, guys, is you get your geotech. He basically goes out, takes some soil samples. Now, depending on your site, in my experience, it's normally 3. So they go and basically drill 3 holes and basically come back, and they go to a certain depth until they get the bearing capacity that they need. And I'll actually bring up later on what an actual geotech report looks like as well if you haven't seen one. So what he does is then basically classifying the soil. And the classification of the soil is what you can see here. So we've got our A, our S, our M, H1, H2, and our E. And we'll talk about our P a little bit later on. So this is basically what they are. So if it's an A, it's mostly sand and rock sites with little or no ground movement. S is slightly reactive clay sites. M is moderately reactive clay or silt sites. H1 is highly reactive clay sites, which may experience high ground movement from moisture changes. H2, highly reactive clay sites, which may experience very high ground movement from moisture changes. And then an E is an extremely reactive site which may experience extreme ground movement from moisture changes. So then you'll see when we get down here, it then talks, you'll notice there's no P in there. And I know my house that I'm living in at the moment was built about 14 months ago. It was a Class P site. And so it talks about what a Class P is. And it says that basically it's well, classification of other sites. Sites with inadequate bearing strength or where ground movement may be significantly affected by factors other than reactive soil movements due to normal moisture conditions shall be classified as Class P. Class P sites include soft or unstable foundations such as soft clay or silt or loose sands, landslip, mine subsidence, collapsing soils, and soils subject to erosion. Erective sites subject to normal moisture conditions, and sites that cannot be classified in accordance with clause 2.1.2. So, and you'll see here it then talks a bit about our bearing capacity. And so the bearing, so it says a site shall be classified as P if the bearing strength is less than what's specified in 2.4.5. There's a few others, I won't read through the whole thing. But that's when we go to 2.4.5, and that's I'll let you guys find that later on, because that's then when it starts to talk about our bearing capacity, and it talks about, if we've got basically the foundation level shall not be less than 100 kPa for strip and pad footings, and then or 50 kPa under all beams and slab panels and support thickenings for our slab constructions. So basically, if it's not going to meet those requirements, that's when it's going to become a Class P. So that's just a little bit of background on what our soil classifications are. And now when we do this, guys, it's really tonight's subject. A lot of the answers we can find, you can find them in the Building Code of Australia, or you can actually find them in Australian Standard 2870. So it's really up to you, whatever works for you. It's sort of, me personally, I just use the BCA because I use it for basically all sorts of stuff, and rather than be carrying all these different standards around which we've all got, I've just found that that's something I used over the years, and I probably didn't own that many Australian standards because they were so bloody expensive. So I just got used to using the Building Code of Australia. But in saying that, the section in the Building Code of Australia to do with our slabs and footings obviously isn't as comprehensive as what the Australian Standard 2870 is. So the downside is, for me, I go to the Building Code straight away, or you guys might call it the NCC, and I look there first. And then sometimes it doesn't always have it, so then I've got to go and filter through the Australian Standard 2870. So it's really up to you, whichever's going to work for you. So you might see me tonight referencing basically the building code, and you might go, I actually found that in Australian 2870. It doesn't matter as long as you're finding the answer, because it's going to be the same answer in either. So whatever works for you, and you can navigate through quickly to find your answers, just use whatever is best suiting your needs. All right, so another thing which I'll just show you, I won't go through it tonight just because of the time restrictions, but I'll email this out as well. What they've done with the online version is given me a few, I suppose, extra training aids that you wouldn't have seen in your classroom. So one second, and I'll just bring this up, and It's just a bit of a definition on all the different footing systems that we use. So it just talks about here about how we go to 2870 for it, and when you come down, it talks about trench mesh, our slab fabric, and how it's basically called like with our trench mesh, how it might be 3/8 TM, and that means that we've got 3 bars and it's an 8mm diameter steel, and the TM is then that it's trench mesh. And then our slab fabric, it says previously called F62. I don't, maybe I'm not old enough to remember being called that, but now is SL62. So you might see we're doing stuff tonight where it's got SL82. So what that means is that it's a fabric mesh, and it's basically 6mm bars welded together in a 200 square grid, and the sheets are 2.4 by 6 meters. And yeah, and basically they have an effective strength of 300 MPa. So it gives us a little bit of information on that. And then it talks about, this is the stuff that comes straight out of our standards in our building code, about what our minimum MPa and our aggregate has to be. And then it goes on to a little bit about our pad footings, and says, yep, they're also called blob footings. It talks about when we would actually use those. And then it gives us a little bit of a picture showing us what isolated piers are and our pad footings are. So when we're doing stuff next week, when we do our subfloors, and we see that we're doing stuff on piers and we're talking about our subfloor ventilation, then this is what we'll be looking at here. And then it talks a little bit about our strip footing. It's the same thing. It talks to us about what it is, what's the process of it. So if you've never done a strip footing before, it says we dig the trench with backhoe or by hand. I'd hate to be digging it by hand, but if you're down the side of a house and you can't get a backhoe in, maybe you do dig it by hand. Then we tie up a reinforcing cage, lay the reinforcing in the trench, and then basically make sure it's got the adequate cover for our concrete and so on around it. And then it talks about in there what our cover should be. So if you're not familiar with what cover is, guys, it's the amount of concrete basically surrounding our reinforcing before it either touches the ground or the black plastic membrane that we've got in there. So it gives us a couple of pictures. It shows you, yep, they've got looks like a cage in there. It's not just a layer of trench mesh. They've actually made up a cage with ligatures, I think. Then they've basically poured it afterwards, and as you'll see, they never finish at a ground level. It's got to have basically a measurement from ground level down, and we'll cover that tonight when we use our standard. So it does a little bit in there basically on our strip footings. Then it talks here about our pier and beam construction, and basically shows how that works, and then our pile and beam. And then it talks about our slab on ground. Sorry, it talks about raft slab there as well, sorry. Slab on ground, and talks about our footing slabs. And you might find that this terminology might differ slightly to what's in the standards, but by reading it, you'll understand it. And there's our stiffened raft, which we'll be covering a lot tonight. That seems to be pretty big on what they're testing in the VBA at the moment. And it gives us a little bit of a picture there on how sort of the grid system works on that. And then obviously our waffle raft, and it's showing it there. So yeah, so what I'll do, guys, I'll email that over to you. You might go, hey, I'm all over slabs. So as I said, anything I send over, if it's not for you, just delete it. But I'm someone who thinks it's better to have too much information than not enough. So I will forward that over. I just thought I'd explain it to you before I basically send it over. What's this? I've never seen this before. All right, so what we might do, guys, just to get us started, is I just think when we look at our Australian standards, that the first 3 things that I tab is basically the page for our stiffened raft, for our waffle raft, and then also for our strip footings, because they're basically the 3 different types of basically slabs and footings we're going to be questioned on when we go into the VBA. So if you've got your Australian standard there, basically the stiffened raft starts on page 29. So let me come down a bit here. So there's our stiffened raft. So that's basically where a stiffened raft starts. So if you haven't actually got basically a tab on there, I'll chuck one on there as your stiffened raft tab. Then the other one we're going to have is our waffle raft, and it starts on page 33. Which is this section here. So I'd chuck if you haven't got one already, just chuck a tab on the side of your book that says waffle rafts. And you'll see that whenever we go to any of these sections, you'll always give us a bit of a definition, which is highlighted here, and we'll talk about these a little bit more later on. And then it'll give us a table on how we work out what our reinforcing needs to be, what our alternatives are for bars, what the depth of our footing is, and then what mesh we're going to use. So you'll find that they work basically sort of in their own chapter. So when we go to that last part that said our stiffened raft, it'll give us an explanation, give us some drawings, then it'll give us a table. And then when we move on to our waffle raft, the same thing again. And then the next one that we want to put a tab on is our strip footings. So strip footing starts at the bottom of page 36. I'll just scroll down. It's just here. So it basically talks about our strip footings on the bottom of page 36. So as if I was you guys, chuck a tab there. And then once we come over, there'll be some pictures explaining, and we'll cover this stuff a little bit later on. And then we'll come down, we'll talk, there's our spacing of our beams. And then basically there's our table where we work out with our soil classification, what type of construction we're using, to what our depth and width is, and then our reinforcing. And so I would just basically tab all those ones there to start with. And from there, what I like to do is just do a little bit on our stiffened raft slab, because that's the one we seem to get tested on the most. We'll do a couple on that tonight, guys. So I think the first drawing that we want to pull up, so bear with me 1 second and I will just bring it up, is this one here. So I'll just get rid of this for you. So it does say so we'll do this anyway, because it says trainer to give the specific detail. So what I've done, guys, is actually just made it for a Class S site. So if you guys basically want to work out that drawing there to a Class S with articulated masonry veneer, and what we'll do, we'll say that the slab length is basically 22 meters. So therefore you can then determine basically what fabric mesh we've got to put in there, and we should hopefully be able to detail that. So if you go to your Australian standards, and basically we should be able to then work out, from the table, what the depth of our footing is. We can draw in where our trench mesh goes, and basically how thick this has got to be. These measurements, because these two walls, guys, whilst it doesn't show it, are load-bearing walls. So what's the distance from that load-bearing wall to the basically the center of our internal beam, and then our slab thickening, how wide that's got to be, and then how deep it's got to be. So fill in that detail. You'll probably find that some of it probably might not change from the first time you did it, but I think it's a good exercise just to practice basically working out the mesh, working out what the depth and the widths are. So do that on a Class S with an articulated masonry veneer and a slab length of 22 meters, and then that way we can work out what our fabric is. So once you've done that, just type in the box done, and we'll basically go through what those answers should have been, and then we'll move on to something else on our stiffened raft. So yeah. Yeah, mate, I'll send that over to you, Luke. Do you want to, yeah, actually, give me a second, Luke, and I'll email it. So Luke's just asked me, could he get a copy of 2870? So if anyone else needs that, guys, just let me know, and I'll email it over now. So this is your first time, isn't it, Luke? I won't have your email. I'll get it out of the system. That's right, isn't it? Yeah, Ben wants one too. Yep, cool, no worries at all. Class S, please, Thomas. So we'll go a Class S. Well, just 1 second, Jeff. I'm just sending over an email with these standards, and I'll run you through it. Just give me 10 seconds. All right, guys, those blokes who needed 2870, I've just sent it now, so hopefully it should hit your inbox pretty soon. Yeah, so what we're so what we're doing, Jeff, is we're just doing this one here on the basically on the raft slab, and I've just given the guys a scenario that it's a Class S site. It's got articulated masonry veneer, and the slab length is 22 metres. So from there, we're just going to go and detail it, basically how, basically give us the depth and the width of our beams, basically the spacing, make out these load-bearing walls, so how far that is. So you just basically detail that as if it was an assessment based on a Class S with articulated masonry veneer. Give me a second, Greg, and I'll get to that one. I actually got your email today too, Greg, and I just hadn't had a chance. I'll tonight send over some stuff that I've got. I don't know how new it is though, but I'll send it to you. And if you've seen it before, yeah, by all means, yeah, that's all I've got really. But hopefully it might be new to you. Yeah, so with that load-bearing wall, so what it is, it's got to be, basically it can't be any further than basically 1 metre away from the internal beam. And yeah, so it's reading question. Yeah, so basically if it's any further than 1 metre away, basically that's when we have the like the slab thickening underneath it. Or is that, or are you asking me, is that the minimum or is it the maximum? Sorry, that's what you're asking me, aren't you? Okay, I'll have a look at the picture. Oh, sorry, mate. I'll take you off mute. Sorry, I forgot that because of the feedback before. Mate, I'll just unmute you. 1 second. I'll see how we go with the feedback. If I get lots of feedback, I'll just mute you on your own. Yeah, so sorry, you were talking and I had you on mute.
Yeah, no, but I typed it there. I'm just meaning that obviously slab thickening doesn't, like, the load bearing has to be directly over the thickened slab. It's not one. It can't be 1 meter away from the thickened slab. It's only 1 meter away from the internal beam.
From the internal beam, yeah.
Makes sense.
Yeah, that's spot on. Yeah, cool, mate. No, sorry, okay, I'm just going to turn you up on my headset. I've got my headset turned down a little bit. Yeah, cool, mate. Yeah, so is that good?
Yeah, makes sense. It's logical. I was just kind of curious.
Yeah. All right, cool. So yeah, so don't forget, guys. When you're done, just type in the box that you're done, so you're not all sitting here waiting for me. And I've got you all off mute now too. It looks like the feedback stopped. So yeah, anytime you've got any questions, guys, just you have to type now if you've got a headset there. And Yes, you had a question here about the difference between the stiffened raft and the waffle rafts. So we'll talk about that coming up. But basically, in a nutshell, what happens with the stiffened rafts, guys, basically has the sand underneath it, and the waffle raft we use basically the waffle pods. And the way that they effectively do the same thing, but what that happens is if I scroll down here, and I'll cover this when we do the waffle raft. Basically, the waffle is basically what creates the beam here is basically the space in between the two waffle pods. Whereas with obviously the sand, we put that sand in there, and yeah, those beams are then normally wider, and you'll see the difference when we do that a little bit later on. And basically, when they do the waffle raft, they call it the stem width, and yeah, it's sort of one of those things. Like in my experience, it's really something that the volume builders do, and obviously it's got to be signed off. It's it's not like it's a dodgy way, but it's in my experience, it's a much quicker way of doing a slab. Is basically come down, cut the slab, basically so it's all flat. You basically put your formwork up and just pop the waffle pods in, put the steel on, you're pretty much ready to go, rather than putting all the sand and all the digging and everything else. So yeah, each to their own. I know a lot of people aren't the biggest fans of the waffle pods, but at the end of the day, if that's what's designed, a lot of the time we don't have too much of a say in it. But yeah, so we'll cover a bit more in detail what the difference is a little bit later on. And did those standards come through, guys, for the guys who are after them? Yeah, cool. Yeah, cool, Valvent. So is that something you want a hand with now, or you mean just want a little bit extra at the end? Yeah, cool. No worries at all. So what we should be doing, guys, I might just bring up the standard, just so if anyone is struggling, because there might be some guys first time doing this. So let me get up to the page that it's on. Just give me a second.
Okay.
All right, well, so as we can see here, that this is a drawing that we want to be getting out of our Australian standard. So we should have gone, if you're wondering how we got here, basically what we should be doing is going to the stiffened raft section of our Australian standard, which starts here in section 3.2. When we come down, there's some things that just don't change. So they're going to be basically the width of our footing here, basically that angle on there, and that's something you'll probably see in a multiple choice, and it says what is basically the maximum or minimum, I forget how they word it. Oh, some guys getting feedback, so let's chuck it on mute again. Basically that is the I think they call it the transition from slab to beam, and the answer is 50 mil. So if you've been practicing your multiple choice, that's what that's getting at there, is basically I don't know if you can see my mouse or not on your end, but that's obviously the slab on the top transitioning into the beam. So that's a measurement of 50 millimeters. So things like that don't change. So unless we'll cover something a bit later on, if you do dig it too wide, but normally it's only going to be 300 mil unless you use a bigger bucket. And then obviously the width of our slab or the depth of our slab, 100 mil. These things don't change with our load-bearing walls. So the only things you need to work out is then by using the Class S slab, so the Class S soil, is then going into this table. And we go Class S, and it was articulated masonry veneer, and that then tells us how deep our footing is, what mesh we're going to use, and so that is then how we get the answers for these ones here. So that depth there, you'll get from the table, and then this mesh we can work out from using that table. So yeah, so just don't forget to let me know when you're done, guys. Oh yeah, so Ben, with that, I honestly don't know. Yeah, because it's the interview, I would take it, and then that way, if he wants to see anything, because normally they obviously don't like you to reference anything out of like soft copies when you go in. But yeah, mate, if you're going in for an interview and you've got lots of your work stuff on there, but me personally, I would take it, and then if he says, hey, listen, you can't use that, just go, okay, no worries at all. But yeah, if you've got a lot of your stuff stored on there, if it was me personally, I would take it in. Cool, thanks, Hubert. Yeah, cool, thanks, Tom. Cool, thanks, Michael. Cool, thanks, Luke. Cool, thanks, Ben. So with that saying, so this is a question here from Ben. Are you talking about like soft copies that I've got, or are you talking about ones to take in in the interview, Ben? Yeah, mate, I'll just take in as much as you can. At the end of the day, if he doesn't want you to use your laptop, then he'll just tell you. But yeah, I'd put it. Yeah, if you've got a lot of your work stuff on there, whereas your schedules, even like your costing systems and stuff like that, if you've got all that on your laptop, which most of us would, I don't think many of us are that old school where we're still using a ledger and we're handwriting it all in. I'd be taking it in. Oh, sorry, Dean. If you just asked me, I just popped up there, Dean. Did I answer your question that you put in there, Dean? Or were you just telling me that you'd finished? Done. All right, cool. I think that might be all of us, guys. If you, yeah, mate, yeah, that retaining wall one I'd take in for sure. Yep. All right, so I think that's everybody, guys. If you're still going, definitely let me know because I don't want to move on if you're still doing it. As it's just the box where you guys type into me, I can only see about 5 things there, and then it gets moved on to the next one. So I think that might be everybody. But if it's not, just say, "Hey, Adam, I'm still going," and basically I'll just wait for you. I'll just take us off mute again. So if it is your first time, guys, what I normally ask you to do is just to mute yourself on your end, and then that way it stops any feedback coming through. And then when you want to talk, rather than type to me, just mute yourself and just chat to me, then chuck yourself back on mute. So if you can do that, and that way it makes it a bit more interactive, I suppose. And if you're like me and you're a slow typer, it probably takes you a while to type your questions in. Yeah, no, it doesn't look like anyone says that they're still going on it. So we'll go through this, guys, and so what we've got there, so we should pretty much have, as I said, a lot of these things actually don't change. So we still should have basically those measurements that we can see, and the ones that would have changed would have been the depth here, which should be 300 millimeters, I'm pretty sure, and yeah, that might be a good idea, Greg. I'll do that for the next one. I'll ask her to basically do it, so then I don't have to keep saying it at the beginning of every session. Yeah, cool. So yeah, the depth should be 300 millimeters. Our trench mesh was 311 TM. What else do we have here that I wouldn't have got? Our fabric mesh was SL82. And I'm pretty sure the rest of it, we didn't have to find out too much more, I don't think. I think the rest was just basically referencing those pictures. So, yeah, hopefully if I missed anything, just let me know, but I'm pretty sure that should be the only ones that we had to cover. I got the trench mesh there as 311 TM. So let's have a look. I've been known to make mistakes, especially when I make up something off the cuff. So what we said it was going to be, on its articulated masonry, I said, didn't I? So that would make it that one there, wouldn't it? So the 3L8 TM. Does that sound right? I did say articulated on a class S, didn't I? Yep, cool. Yeah. So there you go. That's right. All right, cool. Yep, so everyone's going, I got that wrong, but actually I got it wrong. So there we go. All right, so what we'll do from that one there, guys, is we'll do another one. Just I like to sort of keep these, we'll do like all stiffened rafts, then we'll do waffle pods, and then we'll do strip footings. And then at the end, we'll go through basically the questions. So whilst we've just done a little bit there on our stiffened raft slab, what I'd like to do then is basically I'll bring up this other document. So just bear with me 1 second. All right, so this one here, so some of you guys, if you've done this course before, you would have already done this one, but what we can do, I've actually done this up as another exercise as well, but I'll just talk through it basically to start off with. And so we're going to do this on a Class M articulated masonry veneer. And so what we need to do is draw in our reentrant bars. So guys, if you're not sure what reentrant bars are, basically at our internal corners, I don't know if you guys can see my mouse, but you can see the internal corner here. Basically we have to put a reentrant bar in there. So when we can either find that in our Australian standard or in our building code, and basically it tells us, you know, what size that needs to be. So when we draw it in, so let's draw in where it goes and then also nominate what the size needs to be. And then looking at our last drawing, we can then basically, this is what is the maximum offset of a load-bearing wall to an internal beam. So we can write that in there. And then we're going to draw in what our beams are. So with our beams, guys, basically when we reference our table, it's going to tell us what our spacing of our beams should be. And so it is actually in our Australian standard, and we'll do a little bit more when we talk about our continuity of beams and so on. But what I'd like, I just use this lesson, I suppose, where I don't want to feel like if you're doing it for the first time that you're totally left and you're lost. If you're lost, I'll put you in the right direction. But I think it's a good way to start, I suppose, rather than me putting everything on the screen and showing you guys, to sort of, okay, point you to the direction and say, this is all going to be in our stiffened raft, and therefore you sort of read through those, and there might be a reference where it'll point you to the back of the book under a certain clause to talk about continuity of beams and things like that. So if we look in our stiffened raft section of our standard, we should find a lot of this. The generic stuff basically around our what is a nominal slump of concrete, the nominal aggregate, that will be in our standard and also in our building code. So it won't necessarily be under the stiffened raft because that is generic to all our slabs and footings. And then the same with our bearing pressure and our vapor barrier. So let's just have a bit of a crack at it. And I said, if it is your first time doing it and you're totally stuck, just say, hey Adam, can you give me a hand with this? And I'll put it on the screen and show you how we get there. But basically, the starting point for the reentrant bars, yeah, that'll come under your reinforcing. So I use the building code for a lot of this one, guys, to be honest with you, because I just find obviously the section isn't so big in the building code. So I find the reentrant bars out of my building code. Then I find the slump and the aggregate out of the building code as well, and also the minimum edge rebate. So it is in the standard, so it's whatever's going to work for you. But let's have a crack at that. And the guys who have actually done this one before, just give me a second, and what I'll do is basically give you guys a different scenario, so then you guys can have a crack at that as well. And sorry, someone just was talking to you. Just give me 1 second, and I'll get back to you. So the guys who have done it before, if you're in a different scenario other than the Class M, I'll just pull out the one I've got drawn up here. Let's do a Class H1 with articulated masonry veneer. Let's have a go at a H1 there, guys, and see how you go with that. Oh, sorry, I think there was someone there trying to have a chat to me. If you were, basically fire away. I'll stop yapping for a second. Mate, you're all good. Might have just been a bit of background noise. And when you do it, guys, don't forget to do the little sectional down here as well. You can draw that in with your trench mesh, basically how deep it is. Maybe put in your membrane, how much cover needs to be on there with your mesh. Yeah, so with the slab length, Michael, yeah, just do your sums. Hopefully, just I'll minimise that a little bit, and just yeah, do your tally up there, mate. And what's that going to come to? Roughly 18 odd meters. Make that a little bit smaller. Oh, it's way too small, isn't it? Cool. Okay, that's all right, Valavan. Do you want me, I might start taking you through it now while the other guys are working through it, and I can basically start to take you through how we actually did this, if you like. Are you happy with that? Yep, and don't feel bad about this not being your strong point, because to be honest with you, I would dare say that probably not many of the guys in here, this is their strong point. I know that when I was an apprentice carpenter, we used to do all our own slabs, and basically once I finished my apprenticeship, hardly ever after that, it was just basically the truss was put into the concreters. We had a good bunch of concreters, and we would then normally rock up once the slab was done. So yeah, this is probably something that we're not overly familiar with, especially when the different types of basically all the different types of slabs. All right, cool, no worries at all. So what we're doing here, mate, this is actually a basically a raft slab. So how we actually can know that is just by also the drawing here. So normally when we go into our interview, it'll tell us a raft slab, hopefully, but if it doesn't, the way you can tell is by this angle here as well. So I don't know if you can see my mouse or not on your end, but on that sectional, see how it's not square and it's on like a 45 degree? So that gives away that it's actually a raft slab. So what the raft slab is basically where they come and put the sand in, and then that creates basically some internal beams. So without giving you the answer too much, basically once it's done, this is sort of the answer for an exercise like this, but done on a different soil classification. So looking from above, inside these red squares is basically all the sand, and then what that does, it gets basically creates these beams of concrete around it. So that's those beams of concrete determine basically how deep they are is determined by the soil classification, and then also what our cladding is going to be. So back to here, the first question we've got, it says draw in the reentrant bars. So if you were to open up, one second, I'll just pull open my building code. And one second, mate, I've just got to bring it up, and then I can show you what we're looking at. So on the building code here, so it says draw in the reentrant bars. Now this will be in your Australian standard as well. I said I'm just used to using my building code. But if I come down to page 142, let's make this fractionally bigger so we can all see it. So this here is giving us like some our stiffened raft as well. So you can see that it's got pretty much the same table in our building code. So let me come back up. So this here is talking, so if running which section I'm going to of the building code, basically it's in our slabs and footings part, footings and slabs, sorry. And when we come down, there's a picture here that says reinforcing at reentrant corners. So that's what we're getting at there. You see how there's internal corners. we have to put reinforcing on those corners, and that's called a reentrant corner. So it tells us that basically that it has to be 2 meters long, and it says it has to be in accordance with 3.2.5.3. So if we come down, or go back up, sorry, 5.3, this is where it'll talk about here. So a reentrant or internal corner, 2 strips, a minimum of 2 meter length of 3 L8 trench mesh, or 1 strip of 3 11 trench mesh, must be placed diagonally across the corner. So that tells us, you know, what type of bar. So it's got to be 2 meters long, and if we use basically the three bars at 11 millimeters thick in the trench mesh, that's what we're going to do to place across those reentrant corners. So that's basically, one sec, I'll just bring up the picture again. Oh, 1 second, mate, it's just died. I'm going to have to bring that one back up. So that is the first answer for the reentrant bars. So then the next question says, what is the maximum offset of a load-bearing wall to an internal beam? So is it? Yeah, it is, mate. It's always 2 meters. So like it can be longer, but remember, this is always going to be the minimum. So if you had, you know, a bit lying around and it was, you know, 2.5 meters, you probably wouldn't bother basically cutting it off. Just save your time. You just chuck it in and you tie it off. So just remember, everything we're doing with the standards is always going to be the minimum, and we'll see that more in the coming weeks when we start designing wall frames and so on. And you'll look at it and go, geez, I wouldn't use a timber that small, and it's because, you know, this is a minimum, and we always go that little bit extra. So as that if you had a bit that was longer than 2 meters, yeah, you just basically you just put that in, unless you could cut it in half and use it somewhere else. But if it's only got a few hundred mil that can't be used anywhere else, you just basically you would throw it in there anyway. So sorry, 1 second, I've got a question there from Ben. Yeah, so if you want to maybe just wait on that one, Ben, and when I get to explaining that one to Valavan, and then I'll cover that one when I get there. So, but it'll be, if you just leave that one and I'll go through those as we get down there. All right, so then it talks about what is the maximum offset of a load-bearing wall to an internal beam. So that was just that picture that we drew before. And hopefully if I scroll down, I can find it. So this is basically that picture there. So it's showing us that basically we've got a load-bearing wall here, and from our internal beam, basically 1 meter. So you can see there, that's what that measurement is. From the center of the wall frame to the center of the internal beam is 1 meter. And then that would happen if it was going to be further away. That's when we put this little bit of slab thickening. Now tell me, can you actually see my mouse when I'm moving it around on here? Because I always use it to point with stuff. You can, cool. Yeah, because there's no point if if I'm using my mouse and you guys can't see it. So yeah, so that measurement, so when we've got a load-bearing wall, so that means that it's obviously holding up our roof structure, and as that weight's being transferred through our load-bearing wall, the slab that's only 100 millimeters thick isn't strong enough to support that. So that's why we need either a slab thickening underneath it, or we can have it an internal beam, as long as it's no further than 1 meter away. So that's basically what the answer for that one there would be. Oh, let me bring that back up. So the answer for number 2 then is 1 meter. Now it asks us to actually draw in the beams. So if we go to our table, let me bring up our Australian standard. 1 second there, guys. Right, so what I'm in, guys, so I'm in now, I'm still in the stiffened raft. And so what it does, it talks about how we've actually got to basically space those beams. So I'll read through this. So it says, internal and external beams shall form an integral structural grid in accordance with clauses 5.38 and 5.39. So we'll go to those in a second. So where the number of beams in a particular direction satisfies the requirements of the maximum spacing given in figure 3.1, the spacing between, sorry, I lost that there. The spacing between individual beams may be varied provided the spacing between any two beams does not exceed the spacing given in figure 3.1 by 25%. So we'll come to figure 3.1. And this is where it starts to talk about down here, basically what our spacing of our beams is going to be. So when we look at our, let me find the thing that I'm after. No, I've lost it. 1 second, I'll bring it back up. So when we look at this one here, so this is basically showing us our beams going through. So when we know what these spacings need to be at, if I come back to my Australian standard, when we look at our table, so depending on which version you're doing, if you're doing it for the first time, the one that you would have in front of you says that it's Class M articulated masonry. So we're going to come down here, so it's Class M, so it's articulated masonry veneer. It tells us the depth of our footing. Don't worry too much about that one there. And then our trench mesh, we'll talk about those a little bit later on, but it talks about our maximum beam spacing. So basically it's 6 meters. So when we come back to our, and don't worry too much about this one that I'm putting up because this is done for a different soil classification. So all we would do, because it says that it can't be, we're obviously going to put one always around the outside, and because on our table there it says the maximum was 6 meters, we can see that wall on the one that you would have in front of you says that it's 8 meters wide. So therefore the spacing in between those two is actually going to be bigger than our 6 meters, which is specified in our table. So therefore we would just run one straight down the middle. So we'd run one straight down there, and yeah, it's just best practice to put it in the middle because that's just basically what we do. So then when we talk about, I'll go back to the Australian standard. So bear with me a section, with us, sorry, with me just a minute. Let me bring up the Australian standard. So when it was talking here basically about our beams, and it said to go to section 5.38 and 5.39, it starts to talk about when we put our beams in that they've got to be continuous all the way through. So we'll go and we'll have a read on that section. So where's it? 5.3.8. I'll just find the page on that. Bear with me a second. So it's on page 50. Okay, bear with me 1 second, Ben. You might be right. I might have been going off my other plan. I've got about 3 different plans here to help the guys with. So bear with me 1 second, mate. I've probably just gone to the wrong page, mate, because I was looking at the wrong soil classification. So I'll just keep going with this part here. Oh, what's going on? My standards are missing a few pages. Nearly there. Right, so continuity of beam continuity in rafts. This talks about where the raft design includes internal beams, which ours does, the structural continuity of internal and external beams in different rafts, and that's also including our waffle rafts, so our waffle pods, shall be maintained with these following criteria. So internal beams shall be continuous from edge to edge, so they've got to basically go from side to side, and where beams are at different levels, as may occur in a two-pore system, we don't have to worry about that one there, but they've got to be continuous because we're not doing something in a two-pore system with this. And where one side of the entrance corner is less, yeah, so don't worry about that one, that doesn't apply to this one here either, but it talks about, you know, if it's less than 1.5 meters and so on. So, but what we got out of reading that was that when we put our beams, they've basically got to go all the way through like this. So bear with me a second, and I'll go back to basically our question. Sorry guys, just got that many tabs opened up here at the moment, trying to have all these things done. Yeah, sorry, and one other thing too, this is what basically Ben just brought up, that with those internal beams, that when you see on here, it talks about the beam layout restrictions. So when I covered the raft slabs earlier on, and it said, you know, your beam set out as per basically clause 5.3.8 and 5.3.9, you'll see here that the first one in, it says where the raft design includes internal beams at all external corners, the maximum distance between the corner and the intersection of the first beam with the edge beam shall be 4 meters. So as you can see here, basically the first one in is always going to be 4 meters, and then that table that I showed you before, where it had our beam spacing at our 6 meters, that from then on becomes a 6 meters. So the first one here is basically always going to be no further than basically 4 meters in both directions. So can you see that there? It's got 4 meters that way, then 4 meters this way. So that's why our first one's always 4 meters, and then after that we can make it up to basically whatever that table has. And I'm pretty sure that it said on the one we looked at that it was 6 meters. So I'll go back to, so you said when it says drawing the beams, so it said, yeah, so the first one in, and it would still be the same as what I showed you there before anyway, because this is 8 meters, so we could put one straight down the middle because our first one in is going to be 4 meters, and then basically coming this way, let me see if I can find that picture that I had, bear with me 1 second. Yep, so we're going to put one here because that's got to be 4 meters as well. And you can see this one here, that one's 4 meters. And then, yeah, depending on our mathematics on whichever says, so this is here, is don't go too much on this because this is based off a class S, but the same one, it's always got to be 4 meters in on the first one, no further than 4 meters. So then depending on what classification your soil was in that distance, we could space them at bigger than 4 meters if that allowed for that out of that table. All right, so that is then how we would draw in those beams. So hopefully that's made a bit of sense for you with that part. Valavan, does that make sense how we did that? What I'll do too, once we finish tonight, yeah, Kurt's got a few questions coming through. What we'll do tonight, if this isn't your strength, by all means, I can give you a few activities to do, and yeah, you can have a crack at those. I know Subit did that with me once or twice, and then he emailed it back to me and I looked over it. So you don't feel like tonight, come 9 o'clock, this is the end of it. We can talk about it, and I can send you some stuff to basically do on your own and have a crack at that as well. So then when it says what is the minimum edge beam rebate, so same thing again, this would be something that would be out of your standard and out of your building code. But me personally, because I use basically the building code, I know it's on, I've got it marked here, it's on page 134. So let me just bring it up. And this is something that you probably want to tab in your actual book as well, because this will be something that if you're doing a multiple choice, if you haven't got a diploma, more than likely it pops up nearly there. I hate using a soft copy. Here we go. So this talks about our edge rebate. So for you guys too, I presume you're listening in if you're still doing your drawing. So the minimum edge rebate, if you haven't got this one, guys, basically the edge rebate must not be less than 20 millimeters, except provided for in D. So that's in, when you look at D, basically they're not required for single leaf masonry. So that's where basically normally the question I get asked for there is basically 15 millimeters. And then another one which we quite often get in our multiple choice is basically how much can the brick actually overhang the edge of the slab, and that's 15 millimeters. So not something that's asked in that question there we were just doing, but definitely worth highlighting and tabbing for your multiple choice. And I've just got that called my edge rebates. That's what I've got the tab on my book. All right, so we'll go through this next one. These is just the same thing, can be out of the building code or out of your standard. So it says, what is a nominal slump? So, and I'll cover a little bit later, guys, if you don't know what slump is. I'll basically show you that at the end as well. If you can hang around, I've got a video on it that I can show you if you're not sure how they actually do slump. So, but I won't do that now because probably a lot of you guys might do slump tests already anyway. So what is a nominal slump of concrete? So I go to my basically my building code for that, and just let me find it. It's on the building code. I'm just going to shrink this a bit. Actually, what I'll do to cheat and get there quicker. So if you're doing a soft copy, guys, I don't know if I showed this or not before, but if you go Control F, you'll see this pop down, and that's in any PDF. And I'm just going to put slump in there. Save me scrolling through and making you guys all giddy. And it'll show me where slumps basically in the building code. So there it is, basically section 3.2.3. And this is where it talks about the next couple of questions we're going to be asked. So the minimum nominal slump is 100 millimeters. And then also the minimum MPA is 20 MPA. And the minimum size aggregate, the maximum nominal aggregate is 20 millimeters. So that's where you can find just in concrete and reinforcing. And saying a lot of you guys, if you're doing your multiple choice, you might actually know these off the top of your head anyway. But if you don't, it's worth chucking a tab in your building code and basically just highlighting those ones there, because that's something you'll probably more than likely get in a multiple choice as well. So that one basically, we'll cover what our nominal slump is, the aggregate. Next one's a little bit trickier, and it talks about what is the allowable bearing pressure of an edge beam connected to the slab. So same thing again, this is going to be in your building code and in your Australian standards. And I've got it just marked in my Australian standards because I just find that, my Australian standards in my building code, just because this section is a little bit smaller, I find them easier to find. I've got it marked here on page 130. And I'll just show you something that I would basically highlight and tab this. Bear with me a second. And the worst part is because I've actually basically using the soft copy, I haven't got all my highlighted parts on it. But you can see here, so foundations for footings and slabs. So if you're wondering, hey Adam, how did you actually find that? Basically the section that we're going to is basically here it says preparation under excavation for footings, and then it just scrolls on and we'll come down here and it starts to talk about foundations for footings and slabs. And this is where it tells us our different KPAs. So it says slab panels, load support panels and internal beams must have a bearing pressure of not less than 50 kPa. Edge beams connected to the slab, not less than 50 kPa. And there's another one here somewhere here where it talks about 100 kPa. So yeah, pad footings, strip footings and edge beams not connected to the slab must be on natural soil of not less than 100 kPa. So there's a couple of your measurements there in your kPa if you wanted to basically highlight those. And that was basically the answer for number 7. The actual answer was 50 kPa, the first one I showed you, which was what is the allowable bearing pressure of an edge beam connected to the slab? And then these next ones, what is the minimum overlap of vapor barrier? So the vapor barrier, guys, is obviously our black plastic, and it's going to be in the same sort of section of our building code here. So I scroll down a little bit. And also it'll be in your Australian standard, but you can see here's a section now still in our preparation part talking about vapor barriers, and it talks about how thick it has to be. So it's got to be 0.2 millimeters thick, medium impact resistance, so obviously we're not piercing it when we're walking on it and there's rocks underneath it. And then it talks about the installation, and it talks about that it states that it has to be lapped no less than 200 millimeters at all the joints, and then also goes on to talk about not that it's part of this question, but just for your own knowledge, basically how do we actually have to manage that vapor barrier around our penetrations. So it's got to be tape or sealed with a close fitting sleeve around all surface penetrations, and then fully sealed where punctured unless for surface penetrations with additional polyethylene film and tape. And you can read more and more on that, but the main thing that you guys are going to be asked in your multiple choice is the 200mm lap on that black plastic. So nearly through these questions. Basically, yeah, we did cover there what is the minimum MPa of a slab, and we found that was basically 20 MPa. So MPa, guys, stands for megapascal, and that's how they actually test the strength of your concrete. So if you're not sure, if you're working commercial, you might have seen it. They come and do like a cylinder test where they actually take the concrete away, and it's in this big cylinder, probably a bit bigger than a Coke can, and they take it away and then actually crush it. Actually, if you're interested in this stuff too, guys, I've got videos on it from other training courses I do. Most people don't really care. They just want to know that it's got to be 20 MPa. But yeah, they basically take it away, and concrete keeps getting harder the longer that it goes. And there's some charts in this video I've got that just shows you, even in a couple of years' time, how it still increases in its strength. So, and they basically crush it and make sure that it's at the strength that it should be at that time of the crushing. And then the last part here was fill in the missing detail of the section below. So what I'll do is bring up this other picture. So bear with me just a second. Is this one here. So depending on which scenario you guys are basically using, because I knew some of you obviously had done it previously, but it still should look similar depending on what size mesh or what depth your beam is. So whenever we're doing these exercises, we want to make sure obviously that we work out the depth of the beam there. So if you were doing it on a class M, it should have been 400mm from memory. And if you were doing the one that I just sort of threw at you, if you were doing it second time round, bear with me a second and I'll just find it. I've got it here in front of me somewhere. I thought I did, but I can't find it. Maybe one of you guys will help me out. They're all the same? Yeah, no, sorry, I'm thinking of another one that I gave you on class I'm going to do on a strip footing. Yep, cool. So, yeah, the width, basically 300. We should have figured out what our trench mesh was. So I'll go it on the class M. So basically we should have had 311 trench mesh. Basically our cover, so as I said about the cover around our concrete is basically 40mm. Then we can also use our... Yep, cool. Thanks, Greg. Is that a question, mate, or just a statement there for me? Yeah, cool. Yep, and so yeah, basically our cover, and then that transition in there was basically 50mm. That's what you really want to be drawing in there, something that looks like that, and obviously suits your scenario. So as I said, I might just cover off that continuity of beams again. Now, unfortunately, this is only the CAD drawing that I've got. But when we go to our Australian standards, and this is something that you definitely want to tab basically within your Australian standard, are these two sections here where it talks about the continuity of the beams, and then when it gets down to here about the beam layouts. So that's when it's showing us that the first one is always 4 meters, and then once we come back to our table, I've just gone a bit too far. Yeah, on the one I've got, yeah, you're right, Wayne. On the one that I've got there, on the depth for the Class M on a raft slab, for that scenario that I put up, or that's actually in your hard copy, in your folder, should be 400mm deep. You are right there. So just let me get to basically this raft slab, stiffened raft. So when we work out those beams, so this is what we're doing. So the first one's always going to be basically our 4 meters, and then you can see here that as the soil gets worse, when we start getting into our highly reactives, you'll see the beams then start getting a lot closer. Whereas up here, when we're doing something that's on a Class M, it's got a clad frame, so it's not very heavy, those beams can then start to be at 6 meters. So that's going to tell us that the first one's always going to be that 4 meter, and then from there, we can start to basically space them out to what's in there. Now, one thing, this will pop up a little bit later on when we do some questions, is, let me find it, this part here, and this is what I find frustrating about the standards, and probably you guys too, because we look at that table there and it says your maximum beam spacing is 4 meters, 6 meters, or 5 meters, wherever it's going to be. But then we read this, it says where the number of beams in a particular direction satisfies the requirements of the maximum spacing given in figure 3.1. So that's that figure down here. And basically then figure 3.1, so I lost where I was up to. Individual beams may be varied provided the spacing between any of the two beams does not exceed the spacing given by basically more than 25%. So there is actually a little bit of play there for us. So I said if I was doing it in the VBA and they get me to draw it, I would just draw it as per the table. But if you guys are on site and you're wondering, hey, probably now we're starting to take a bit more interest when we see this stuff on site, rather than just be rocking up and and doing the job. We're probably starting to ask questions, why is it like this? And you might go, hey, I've noticed this, why are we able to push that out when the standard says it's only 4 meters, why have we got it out to 5? It's because you'll see that in there, it says can be basically by 25%. So hopefully, and I hope this is not getting too sort of jagged for you guys, with obviously some guys having done it before and some of you not. I suppose with not being able to see what you're doing to actually give you direct feedback on it, I just thought that might be the easiest way to go through and explain that to the guys who are doing it for the first time. So what we might do, guys, it's 7:30. Let's have a little bit of a break. We'll have our 15 minutes, have a bite to eat and a drink. We'll come back, and I'll move on to basically our raft. What's the next one going to do? We'll do the waffle pod, and then we'll go into the strip footing, and then from there, guys, we'll do the questions that are at the end, and I'll hang around and basically go over any of this or set any guys any exercises that they want if they feel they need a little bit more assistance in this area. So let's see it come back in 15, and we'll basically cover it from there, and I'll have a look at your question there too, Valavan, and I just saw yours as well, Wayne. So I'll do those when I come back, and I'll bring it up on the screen so we can see it. Alright guys, welcome back. Hopefully you had enough time to have a little bite to eat. Alright, so Ben, just a few questions popped up when I was just out on my break. So give me a second. Alright, yeah, cool, that's alright. So what I might do with yours, Valvan, I might leave that to the end and we can have a thorough sort of conversation about how this all works if you like, and we can talk about those questions you got there. Does that suit you, mate? We'll do it at the end. Yep, I'll take that as a yes. Maybe he's not back from his break yet. All right, so what we'll do, guys, so that was pretty much basically the stiffened raft. So what I'd like to do is now do a little bit, one second, I'll just grab my last set of plans I've got here. So we'll do a little bit on our waffle pods, and then we'll go on to our strip footings. So the waffle pod basically isn't too much to it, to be honest with you. So what we'll do is I'll bring up the waffle pod drawing that I want you to do. And if you guys have done this course before, or done this subject before, you've probably already done it. This one here, guys, is just you should have that in your folder, and that should just be a matter of going to your Australian standards or the building code, whichever one you like using, and basically filling in those blank details. And once you see the picture, you'll know. Basically, it's basically just the widths on here, the stem depth and stuff like that. So what I might do is just put these in the right directions for those guys who aren't 100% sure. So we're going to come to this is our Australian standard 2870. So we're going to come down to where we find waffle rafts. So apologies if I keep calling it a waffle pod. So here's our waffle rafts, and basically we're just going to go through and basically just draw those in and make sure you understand. There's not too much to these, to be honest with you. Still got its own table here where it gets you to reference, how deep and basically what mesh and so on we put on there, and then the slab, basically the mesh we use for the size of the slab. So yeah, so it's really just very continuing what we did on the raft slab. So we won't worry about doing any of that down here, but we'll definitely fill in this part here. So go through and fill in your drawing. As if you've done this one before, guys, maybe just give the guys 5 minutes because it won't take them long to do it, and then we'll move on to doing something on our strip footings. So you just fill in this one just here. Actually, what we can do, guys, if you have actually done it before, because I will have to give you guys a basically a soil classification. So why don't we do this one here as being a H1 soil with masonry veneer. So H1 masonry veneer, and we'll say the slab is no greater than 20 metres. So you'll probably find a lot of your internal stuff won't change, but you can probably get the depth of your footing and the type of mesh you're going to use. So yeah, H1 masonry veneer and less than 20 metres. I might just chuck it on mute for a second too, guys. Or if you can just mute yourself if there's just a bit of feedback coming through. Yeah, sorry, Jeff, I just saw your question, mate. That's no worries. I'll send those over. Yeah, so with your question, Subit, I'll show you that when we get to do our strip footings. It'll, rather than me trying to explain it, it'll make sense once we do our strip footing. I just chucked it on mute for a second, guys. So if you've got any questions, just type it in the box. All right, guys. What I might do, I might just go through that that waffle raft there and show you how it should look. So when we bring this up, so we should be getting some measurements like these. So basically showing that our slab is 85 millimeters thick, and we've got a 20 millimeter cover. So that's one thing you'll notice when you read a bit more in depth about cover on concrete. Basically, a lot of it's got to do with whether it's exposed to the weather or not, about the amount of cover you've got to have on the top surface. So hopefully we've got, basically it's 85 with 20 mil cover, 110 basically of our spacing in between our two basically waffle pods, or what they call the formed void. And as far as our trench mesh goes, so from memory, let's just scroll down. I think because I just chucked up the H1 masonry then off the top of my head, I think it should be 3L11 trench mesh. Does that sound right? I'll take these off mute so you can talk to me. So we go down to here, H1, didn't we?
Mm-hmm.
Yep, so what I say, I said masonry veneer, didn't I? Yep, so 2. Yep, and so therefore our depth should have been 460. So when we come up to here, basically our beam depth 460, and I suppose our bar, we would better figure out what our bar was as well for internal beam. It would have been 1N16. And I think that's probably all we needed to work out off the table. Oh, then our mesh as well, because it was less than 20 metres, would have been SL82. So hopefully that's covered all the little parts, and then the other ones were just our generic of what we would have got off there. So yeah, that's it's very similar to basically the raft slab, just the other raft slab we were doing, where basically just use the table, and we're doing this now for our strip footing as well. So what we'll move on to, we'll go on to our strip footing. I said, and from there, guys, once we've done this, we'll then go on to those questions. So the guys who have done those, 35 questions, I'll see if I've got any other ones I can throw your way, and if not, I'll get someone on CAD to draw some up and I'll email them out. But let's just have a look at our strip footings. So I'll go to our Australian Standard, and that's not the Australian Standard. We'll come down here and we'll go to our strip footings. So strip footing. So the bottom of page number is 36. Yep, I'll send that over to Ben, no worries at all. So this one starts to talk about our strip footings. So it just says here, just note that figure 3.6 does not include designs for H1D, H2 or H2D. When we come down, so with our strip footings, basically around the outside, I'm just trying to explain this, around the outside of the building, there's a better picture of it down here. When that strip footing goes all the way around the perimeter of our building, normally what would happen is we would have something that looks like this. So we've got our mason, is that the, yep. We've got this basically our masonry, and yeah, me personally, I haven't done anything like this for years, but I know the houses I lived on when I was in Brisbane, basically they were all like this. And so basically we've got our engaged pier here with our bear on top of it, and then basically just our masonry going up the side. And so because obviously that's going to have that masonry on it, depending on what type of frame we've got, the cladding we've got, because sometimes we're going to have, a clad frame. That's what we'll have a look at our table down here. We have clad frame, we can have articulated masonry, we can have, full masonry where it's double brickwork all the way up. That's going to determine what our footing is going to be. And then, as quite often happens, because that's there to support the external skin of the building, these internal strip footings, you might just have, you can have stumps and piers basically in them. And so what I just want us to be a little bit aware of when we're doing this is, because a lot of guys get a little bit tripped up when they do this exercise, that they don't actually understand that there's a difference between the DF, the D, and then the DS. So what happens is here, guys, the DF, and when we're wanting to know what these actually mean, if you don't know what these symbols mean, you go, well, shit, what does DF mean? Because when we come to our table, over here, we've got stuff in here that says DS, LS, D and B, and if you're wondering what these actually are, when we go back to the beginning of our standards, just let me come back. So if you're ever unsure, you always go to basically the front, and it will give us in our glossary sort of section where it talks about definitions. So if you're unsure of what any of the definitions are, so you can see definitions start here. So it tells us what articulated masonry is. Articulated full masonry, what articulated masonry veneer is, and then what articulation is. So if you're reading any of this stuff and you're not too sure what the definitions are, you just basically come to here. So if you go, geez, what's a board pier? What's a clad frame? So if you're not familiar with this, go to the definitions, and it's in alphabetical order. But where guys get a little bit stuck when they're using these tables and they're trying to find definitions, like that one that says DS, when you go, geez, what's DS? You'll come to DS, and you can see that it's not here. So what you've actually got to scroll a little bit further, and you'll find that basically it's under S for symbol. So when we get to symbols, oh, I've gone past it. Sorry, under the notation, and then it says the symbol and the definition. So it's not under S, sorry, it's under notation, and then S says here the symbols and where they all are, and then what the definition is. So if you're not too sure what those little, like the DF, it's the depth of the strip footing from the finished ground surface level. And then the other one, the DS, where people get confused, is the depth of the pad footing from the finished ground level surface. So that's the depth of the pad footing as opposed to the depth of our external beam that goes all the way around. So when I come back to down here, that'll make a little bit more sense now when we look at it. Bear with me 1 second while I get the page. So DF is the depth of our pad footing, whereas DF is the depth of our footing, which is the whole thing there. And you'll see there that basically the footing doesn't go all the way to the top. So when we look at this little part here, if I can highlight it, no, it's not going to let me. It says basically the DF is the D plus 75 mil. So we're going to have a 75 mil from where our concrete finishes to basically our ground level surface. So just be aware of that. It's funny, and one of the guys I trained a little while ago, he was a brickie. and he just used to come basically and do a bit of stuff on strip footings and never knew that it had to actually be 75 mil below. And when he did the course, he was like, oh, I didn't realise I had to be there. He said, I was always cursing the bloody concreters because it was always a pain in the bumper in because it always get dirt and stuff kicked in on it. He'd have to come and clean it all out before he could lay his course of bricks on it. He used to think, geez, why don't they just make it to ground level and that wouldn't have to happen? So it does actually have to be below the ground surface as is there. So yeah, it's just really about getting familiar with our standard, knowing where to find the definitions we're not sure of, and knowing where to find basically those symbols, because some of those do get a bit tricky when we're looking at DF and DS and so on. So what we're going to do is actually, I'll pull up this, one second, I'm just going to close a couple of these because so many of these open, it's getting a bit confusing on my end. So bear with me a second. So we're going to do, we don't want the stiff and rough, we've just done that. We're going to do the strip footing one, so bear with me a second, and I'll just bring up the strip footing. So this one here is the one we're going to do now. So bear with me a second, I'll just spin this around so it's in the right orientation for you. So I'll just see if I've got, so if you guys who have done this before, we might even just do a rough hand sketch. We'll do the same dimensions, but we'll do it on a different soil classification. I'll just see if I've got one here that I've done previously, guys, on a different soil classification. Try and make it a bit more interesting for you guys. No, I don't, but why don't we, I'm just trying to think, the one we've got there is on a H1, so why don't we try and find, we'll do something a little bit different, and I'll work out the answers with you while the other guys are doing theirs. So let's just see what's going to work. So why don't we do, I know, a class M, and we'll do it as, I know, masonry veneer. So do a masonry veneer on a class M, and that way you guys can basically work out what they've got to be and basically draw it in, and we'll see how it looks. So hopefully I can catch up to you while I explain to these other guys. I might just write that down because I'm likely to forget what I told you. So class M, masonry veneer. All right, cool. So back to the guys who are doing this for the first time. So when we go through these questions, it says, what is the beam requirements for the strip footing detail? So when it says the beam requirements, it depends on, if you've done this before, some people determine this a bit differently, but when it says the beam requirements, just tell me actually what the depth and the width that's got to be. And then the distance from the internal stump or pier to the perimeter stump or wall. So you'll have to go to that table and find out what the definitions are to access that one. And then what are our reinforcing requirements? Okay, so what do we need to put in our strip footing? And what size trench meshes are going to be? And then some of these, so what is the depth of the pad footing from the finished ground level surface? That was the one I showed you there before when I was talking about the bricky getting a bit upset because he had to clean all the dirt off it. And then these others are just what we did before, the nominal slump of concrete, the minimum MPA, we did that one before. And then this part here, when it starts to talk about number 7, that's just really to try and get you guys to use your standard a little bit. So it talks about what happens if the excavator has used a different size bucket when he's dug it out. So when we get to our strip footings, when we come down to these parts down here, and you start to read through these ones, you'll see there where it starts to talk about that if it's 100 mil bigger, then you've got to put this much extra reinforcing for every 100 millimeter. So if you read through this section, then you'll find the answers in there. So I'll give you 5 minutes, and if you are stuck and you want guidance, just let me know. But if you go to this part here of your basically starting from here, strip footings, you should find most of those answers other than the MPA, those ones we've already covered, from page number 36 to probably about 39. So have a crack, and if you get stuck, just let me know. Yeah, so if you are wondering what a strip footing looks like from basically above, that's what it looks like there. I'm just going to chuck it on mute again for a second, guys. Yep, no worries, Wayne. I'll check it up now. That one? Yeah, no worries, Valavan. I'll send those over for sure. Just let me know when you're done too, guys. So I'm not just sitting here waiting for you. Done. Cool. Thanks, Subit. Cool. Thanks, Ben. Yeah, cool. Luke, no worries at all, mate. I'll start going through it. So I'll go through this one here, guys. It's on the screen, and then what I'll do, I'll start to then tell you the answers for the alternative Class M masonry veneer that we did. So when it says what is the beam requirements for basically the strip footing, so as it is, some guys might have done this before, and some guys interpret that question a bit differently. So I'll show you the two ways they can be interpreted. So if we look at the Australian standard, so I'll bring this up here, and it says, what is the beam requirement? So I just asked you to give me the reinforcing on it. So we come down here, and it's H1, and it's going to be masonry veneer, which is this one here. So it tells me that it's basically 850 millimeters deep by 300 millimeters wide. So sometimes too, there I said, what are the beam requirements? The other part where guys then look at that is, sorry, I've gone the wrong way, is that it starts to talk here about deep beams. And it says all beams 700 millimeters or deeper, as specified in that table we just looked at, shall be as follows. So internal footings shall be provided at no more than 6 meter centers, and at re-entrant corners to continue the footings to the opposite side of the external footing. So that's basically telling us, that because of its depth, that we actually have to do that. So just be aware, that's what I'm saying, you want to start to read on a little bit when we use this strip footings, but yeah, it's always going to be in 2 or 3 pages after that. So then the next question was, what is the minimum distance from the internal stump or pier to the perimeter? Stump, pier or wall, and that was, sorry, wrong way, just out of that table. And that's what this little, if you would have gone and looked at that, those symbols and the notations, it tells us here that it's 2400. So you can see it's only applicable to the H1s, it's not for these other soil classifications. So that was really just an exercise to get you guys, because you probably didn't know what LS was, to actually go and have a look at the notations, find the symbol and go, yep, it's 2400. So the answer for that one was 2400. So then what are the reinforcement requirements? So look down here, basically H1 masonry veneer, it tells us that it is 3N16 bars. And so what you'll find too, guys, if you haven't done strip footings before, you'll notice that whenever we see them drawn in, they've always got a top and a bottom. So just make sure you do that. And on this, it's obviously got the bars. So some guys, if you're not familiar with it, I just was Googling this before to try and give you guys a visual on it. So depending on how you do your stuff, sorry, I'm just trying to bring this over. This is what I would call a cage, and you can see that there. They're basically, these parts going around it are ligatures, and that's basically what holds it all together. So they're basically a square, and depending on how many bars you've got, basically if it's only 2 bars, you put 1 in each corner, and you tie that off, and you can actually just drop it into your strip footing. I've never had them welded, but you can actually, when we're in Queensland, I'm sure it's done here in Melbourne as well, but you could basically get it welded to get delivered and just dropped it in. You didn't have to actually make that up on site. So yeah, we always used to just tie ours. So that's basically, if you did have your top and bottom you want to tie together with your ligatures, that's basically how it's going to look, something like that. All right, so back to the questions. So, oops, wrong one. So then we just worked out our reinforcing requirements. So, oh sorry, I forgot to tell you guys the answers for who were doing the other one. Give me 1 second and I'll just get them out. So for the guys who were doing the other soil classification, it would have been 500 deep and 300 wide. And as far as that spacing goes of that pier or what's it called? We've got there. They're basically the pier or the stump to the exterior wall. It was not applicable for that one. You'll notice there, those guys doing the other soil classification, it's not applicable. And the mesh you guys would have got would have been 3L12TM, top and bottom. And so then we can move on to the next one. So what is the depth of the pad footing from the finished ground level surface? So if we come back down here, the depth of the pad footing. And I've just lost that there. Geez, hang on guys, I've got too many sheets open in front of me. I'll work it out. So it is, it's a H1 masonry veneer, and the depth is 850. Oh no, to the finished ground level surface. Sorry, so that's when we've got to add that bit on. So yeah, that's what I was getting confused at. So when you come back here, remember when I showed you this before, so whichever scenario you were doing, we've got our depth of our footing, which is basically the concrete, but then from the ground level, which was our DF, if we look down here, and I can't highlight it, basically tells us that we've got to add 70, there we go, 75 millimeters. So whatever the depth, whichever scenario you were doing, add your 75, and that gives you that depth of footing. So the next couple of questions were ones that we had done previously, when it says, you know, what is the nominal slump of concrete? So it was 100 millimeter slump, and the minimum MPa was basically 20 MPa. Then question number 7 said, when digging the footing, you used a bucket 100 millimeters wider than specified. What is the footing requirements now? So when we go to our Australian standards, when I was saying just try and read on a little bit further, it talks about it just down here. So in strip footings, and it says where footings are wider than specified width, an extra bar of the same size is required top and bottom for each 100 millimeters. So because we've gone basically 100 millimeters bigger, yeah, depending on which scenario you did, you chuck on a bar, basically that is the equivalent, and to every 100 millimeters that you've gone bigger. So we just put an extra bar in there because we only went 100 mil wider. So then, is there an alternative trench mesh to 3N16? So let's have a look down here. I can't see any 3N16 there. So, no, correct me if I'm wrong. Just I hadn't had that one previously filled out, so sorry guys, but I'm pretty sure I can't see a 3N16 there. So then the builder wants to do basically a garage detail. Can he use an infill slab? So when we read back here, guys, same thing, just as a matter of reading through, and it talks about infill floors. And basically infill floors should only be used for Class A and Class S sites. And so obviously because this basically isn't basically a Class A or a Class S, then no, we can't. And then it says give the height of the DF. Sorry, I must have given that before for one of the other answers, did I? Oh, I did that. Sorry, yeah, sorry. The DF was a 75. I missed the pad footing. Sorry, guys, I misunderstood that. When I misunderstood, I just read the wrong answer. So this one here, when I was talking about it, what is the depth of the pad footing? If I come back to my Australian standards, and our pad footing was this one in here. Sorry, I was getting mixed up with my DF. So the DS, so the depth of our pad footing is the DS, and that's when we come here. It might have been the same measurement anyway, was it? So if you're using a H1, it's 1 meter, and if you were on the Class M, it would have been 500. So sorry, I got those around the wrong way, but I'm sure you made sense now. So basically the DF was the outside one. So that was the depth of footing plus 75. And then the DS was this one here for our pad footing. And it was in this column down here. So it would have been 500 or 1 meter. And then if we were going to basically draw this in, so when we go to draw it in, guys, it's actually just going to look exactly the same. I'll just shrink that marginally. Hopefully it lets me. So when we draw in basically our footings around here, it should look exactly the same as that, because from what we read previously, it tells us that basically they can't be, it's 6 meters maximum, and they've got to go all the way through like that. So when Steve's actually designed this, he's done it so it actually the figures actually work out so it can be exactly in there. And I said exactly a lot of times then. So yeah, and that's center to center. So sorry, I'll take these off mute there. I keep forgetting that I chuck these on when that feedback's coming through. So yeah, so what it is it's center to center. So just like when we do next week, when we're doing, bearers and our joists, when we're talking about spacing, basically it is from center to center. So that's why if you look at that measurement, we worked out how wide our strip footing had to be on this one here. That's why it should work out exactly. We should have it looking like that there. So hopefully for the guys who needed a little bit of assistance with that, yeah, that helped out. And what we'll do is I'll get some of these drawn up on CAD. If I can't get them done up on CAD, I'll just hand draw them and I can send them over and you guys can do some practice ones on it. Because yeah, so this is probably one of the ones I find probably this week and next week the hardest to do online, just because you guys can't sort of show me and say, hey Adam, am I on the right track here? So by all means, I'm one of those people who thinks practice makes perfect. So let's, I'll draw some up, I'll get Steve to on CAD, and if not, I'll hand draw them. And yeah, and we'll send them over and you guys can do a little practice on them if you like. All right, so from there, guys, what I thought we would do, and bear with me 1 second, I'll just bring it up. Is these questions here. So you guys who have done this unit before have probably already completed these. So, they're not going to be any different. So there'd be really no reason to do them again. But before we tackle these, what I'd like to do is just go through my Australian standard with you and make sure that you guys have got this stuff tabbed and highlighted because a lot of it's going to be in this section here. And I normally do it afterwards. So when you do it, you can sort of try and find the answers yourselves. But I'm aware that some of you guys have probably done this before, and you're probably going to log off once I sort of set the guys a task to do this. So we'll just go through my Australian standard with you, and I'll just tell you the stuff that I've actually got highlighted, and then that way hopefully you've got it highlighted and tabbed as well. So I'll put it on the screen as well. So let me bring it up. So my first part that I've got highlighted is actually on page 25. And if you might have it highlighted in your Australian standard, not Australian standard, sorry, in your building code. And it's about the bearing capacity. So this is where it talks about the KPA that we need. And we did cover this one a little bit before. So that talks about our 100 KPA for strip and pad footings under the edge footing or footing slabs used basically without the bars between the edge footing and the slab. And then it talks about them when we use basically 50 KPA when our soil needs to be that. So I've just got that basically tabbed in my book as bearing capacity. So in case you get any questions about bearing capacity, with our thickenings and so on, then you can find that there because it is a little bit hard to find, I found. So I've got that one there tabbed and highlighted. If I'm going too fast with this too, just say, hey, hang on, Adam, I'm still actually highlighting that one. All right, so then, we did do this one before. We'll bring it up again now. So basically on page 29, I've just got it there as my stiffened raft section. So I've just got a tab there that says stiffened raft and pretty much just highlighted this stuff here where it talks about our beam layouts and the different clauses that actually relates to for our stiffened raft. And from there, you can't really go too wrong. It's just a matter then of referencing these drawings and then referencing that table. Then the next one I've got is in the waffle rafts, and that's on page 33. So I've just got a tab there that just says waffle rafts, and basically just that part there. I haven't highlighted mine because there's not much to the waffle rafts. I just know that, basically once I go there, I'm going to find it. So if you want to highlight that stuff there, go for it. But yeah, I've got highlighted waffle rafts. And then, as we spoke about at the beginning of the presentation, I've just got strip footings, so that I can go to strip footings pretty quickly if I'm given a strip footing exercise. I'm sorry, I've gone past where it starts. So strip footing starts just here. So in my book, it's page number 36 on the bottom. And just a couple little things that I just highlighted, like these ones here, I've got highlighted in mine. And then also what the definitions were, so I didn't actually have to basically go back to that symbol book. So I've just got written there what the DF was. Well, the D is pretty simple, but then how the DS is in relation to our pad footing. So whether you choose to do that or not, it's up to you. And then the only other little part I've got highlighted in here is basically just that section there about our deep beams, because that then talks about how 600 centers and they've got to be continuous from the re-entrant corners through to the other side. So that's basically these ones here, showing you that's a re-entrant corner, so it's got to go through to the other side that way and then through to the other side that way. And so if you wanted to, on page number 49, I said, I did show you this before in the building code, but if you're someone who likes to use your standard rather than your building code, I don't know why these pages are blank on mine. Hopefully it comes up. So it starts to talk about our vapor barriers. So that's probably one thing there too. If you're not too sure, guys, how the mesh actually has to be lapped and so on, that's basically showing you there how they interlock with our wires. So you might know that, but if not, there's a good illustration of it, and that talks about the illustration, the methods of basically lapping our mesh, and then about our vapor barriers. So this is where, if you want any information on vapor barriers, basically we'll talk about it down here. And then down the very bottom, it starts to show what we saw before in our building code, where basically what the thickness is and how they've got to actually be basically no less than 200 millimeters on the lapping. So I've just got that there with the tab that says vapor barriers. And then I did show you before also the edge rebates in the building code, but if you wanted to find it in here, basically there it shows us there a picture of our edge rebate. So me personally never done one that little, but it does actually give us a visual picture of what we had in the building code before, where our edge rebate basically can't be any less than 20 millimeters. And then the only other part that I then have is basically when we're talking about our beam continuity, and that's references as previously to take us to 5.3.8. So I've just got it there, beam continuity, and that's in our rafts. And then when we come down a little bit more, there's a little bit more here about it as well. And I think that's all I've got. One other thing I'll just show you, it'll be in the presentation or in the questions you're doing tonight. I doubt you're going to get it in your multiple choice when you go in there. I haven't heard anyone who's actually been asked this, but I'll just show you where it is because it's a little bit hard to find. On page number 71, it starts to talk about basically our foundation performance and maintenance, and a bit to do with trees and so on in there. And it talks about how far away trees need to be planted from different types of slabs, and then also basically what we need to do with our garden beds. Oh, I might have gone one too far, did I? Now this next page here. Oh, they're funny looking symbols. It doesn't turn out very well. So that's basically that part there. It talks about your limitations on your gardens. You'll find that tonight when you do your exercise. It talks about the last couple of questions, something about garden beds and where they should go, and then also about the restrictions on placing trees. So this, I don't know what's going on with the symbol here on this PDF, but basically what that does say, if you're looking on page 71 in your own standard, it's 1.5 times mature height for Class E sites, and then 1 times the mature height for Class H1 and H2, and then 3/4 of the material height for Class M sites. So yeah, that'll make a lot more sense once you open up your hard copy on page 79, and yeah, you'll find that answer will be for one of the questions that you're going to do a little bit later on. So I know we're at 8:30, so let's go through and basically have a crack at these questions here. And so a lot of these, the first couple of ones, are probably, pretty realistic to some of the stuff you're going to get in your testing. And there's a lot there too, just to try and get you used to using that Australian standard, because obviously we can't be guaranteed that everything the VBA are going to ask you is in our curriculum. So we just do exercises like this that are sort of outside the normal scope to try and get you guys to use that standard and find some questions if you're asked something that we haven't trained you. So have a crack at those ones there. And I do actually have the answers for those, so I can email them over. I don't know if you guys, I don't think you've got them in the back of your books, so I'll email those over tonight as well. And then that way, if you don't get them finished and you want to do it tomorrow on the weekend or whatever, you can actually have the answers and see how you went with it. So I'll chill out here while you guys are doing that. And if anyone's got any questions, by all means, just ask me or type them in the box. And yeah, next week, if you're logging off because you've already done that, yeah, next week we'll be going on to our subfloors. One second, Sue, but I'll just check it out for you. Yeah, I've got it on page 71, mate, under point number C. Well, not point number C, point letter C. All right, cool, Valvan. I'll have a look at that for you, mate. Yeah, so when we look at that one there, so when it's basically got the raft slab, let me just come back up to it. So when we're doing with a raft slab, you'll see that it's basically it's always 300 millimeters. So that's what our raft slab always is. So it's always going to be 300. And the only reason it does change is when we read that definition a little bit later on. If someone digs it with a bigger bucket, then you've got to put an extra bar in for every 100 millimeters. But otherwise, mate, it's always 300 millimeters, and the depth just varies, depends on what our cladding is in relation to what our soil classification is. Yeah, no worries, Sue, but yeah, what I'll do, Sue, I'll just email you over the whole standard, mate. just going to start emailing over a few things, guys. Yeah, I'll send over the answers for some of this stuff, and I'll forward that interview that the guy got as well. Yeah, with those extra footing documents, Subit, and if you other guys will, I actually have to make them up. I actually haven't got them yet. So all I'd done was basically just put out some different scenarios based on the drawing you already had. So I'll see if I can get Steve to basically draw some up. If not, I've got one there. It's got the answers in it though. So I'll just have to work out how to get the answers out so you guys can actually attack it, and then I'll send the answers as a separate document.
Adam,
Yep.
Subert here. Yeah, I'm not talking about the exercise. I'm talking about the earlier document you show us.
Oh yeah,
at
sorry,
the beginning.
no, definitely, yeah, I'm emailing that one right now. Yeah, so was this with all the different slabs and stuff in it? Or not that one there, that's just something I'm trying to sort out. But yeah, no, yeah, that one I was going through earlier, I'm just in the process of attaching that and sending it now. Yeah, Jeff, I just emailed them just then. I just had to type in all the guys' emails, addresses. So yeah, it took me a little while. There's about 13 guys on tonight. I'm just going to send you over a couple of things, Greg. So whether they'll not be any good to you, we'll see how we go, but I'll give them to you and tell me if you've seen them before or not. Yeah, so with that, Greg, they haven't actually given us any pictures, but just from generally talking to them, yes, similar stuff to what's in there. Like, yeah, I know that the guy that I spoke to, actually, I'll just see if he wrote it in an email to me. 1 second. What I'll do, I'll forward this over to you. I'll forward this to everybody, actually, guys. This is another guy who went for an interview with Rob Welsh about 2 weeks ago, and yeah, Greg's just asked me about as far as the plans that they sent him. So yeah, from memory, he doesn't go into too much detail of exactly what they asked him to comment on, but you'll see it here. He just says the second plan was a fault-finding one. It had about 10 details circled in red, and he was just asked to comment on basically whether they were correct or not. So he just had to reference it in basically volume 2. And so one of them, the only one he could really remember was they asked, the only reason he remembered this one was because it actually wasn't in there. And it spoke about the fall on a balcony, and it had in there 1 to 200, and he couldn't find it. And he said to Rob Welsh, he said, look, mate, I can't find this in the standard, but I know it's 1 to 100, not 1 to 200. And then Rob Welsh said, oh, mate, it's probably not even in the standard. Oh, it's probably not even in the building code. So other than that, he said the stuff in there was pretty easy to actually find. But I'll forward this over to you guys. And yeah, this was with another interviewer called Rob Welsh. The one I previously sent was through the exam portion. Okay. Oh, so the exam portion, yeah, okay. The guys who recently went through in the exam portion, they got basically a raft slab, and then they were also given basically a subfloor, and that's what they were given just to basically with their work out. They did their, and we'll cover this next week, with their trying to space everything at 1500 millimeters, then work out whether they needed footing type 1, 2, 3, or 4, and then basically their bearer and their joist. So there was that and a raft slab, and then they also got the plans with the roof on it where you had to do the roof layout. So if you've seen those ones with the roof layout? Yeah, cool. Yep. So yeah, if you got those, mate, you should be all good. So yeah, raft slab, basically the subfloor, which we'll cover next week, and then yeah, that roof plan. Cool. So I'll just forward this other interview, guys. I don't know if I did actually forward this to everybody, but just in case, I'd rather forward it twice than actually not have done it to you. Cool, no worries, Luke. I'll send out this other one too, mate. Cool, so it's getting close to 9, guys. I know some of you are going to be out slaving away hard tomorrow on the tools. Not me tomorrow. So yeah, if you need to log off, by all means, that's all I'll do tonight. But if anyone who wants to hang around and have a chat about anything they didn't quite understand, I have emailed you over the answers for these questions here. As I said, I'll get a couple of more exercises, hopefully with some answers as well, so you guys can do a few exercises and then check them in your own time. But yeah, let me know if there's anything you want to chat about now while I'm here. Yeah, because I'm mindful that you guys obviously have to work tomorrow and you don't want to be on here too much longer.
Adam, Subert have a quick question.
Yeah, mate.
You mentioned just now that there's another drawing about roof drawing. Are you talking about normally, are we supposed to do roof layout or just with a roof drawing? I've seen one with a roof drawing that we are asked to names of all the different type of trusses.
Yeah, no, this is, it's pretty hard. I'll show you this one and I'll put up on the screen. I'll email it over. So bear with me 1 second. All right, so let me get the right. So they give you, and Ben had to do this one when he went in. Basically, they give you that plan there with, I don't make it too much smaller, basically with no roof outline on it, and you've got to be able, this is for the guys going for DBU and DBM, and yeah, you've got to draw in your hips. And what makes this a little bit challenging is that because the span of this building here is only 6 meters, not this building, this section of the building is 6 meters, and this one's 6.9. So what happens is obviously the ridges don't line up. And so because they don't line up, one's also higher than the other, because if they're both on the same pitch, let's just say this was, I make it easy figures, 45 degrees, if you could imagine because the base is wider, then the apex where the ridges join, this ridge here is going to be higher than this one. So you've got to put what they call a broken hip in there at an angle of 45 degrees. And then this is what makes it even more complicated, because it's not uncommon to have like an L shape where you'd have this ridge down here as a broken, hip as a broken hip. But what makes this challenging is obviously having the 3 different spans and how that all works. And that's something that the guys have been getting recently. So I can definitely forward that over to you if you haven't seen it. So you haven't seen that one before, Subert? You'd like me to email that over to you? Yep. Cool. And I'll just, I'll email that to everybody as well, just in case, guys. I'm sure some of you have got it, but I don't want you to miss out on it. So I'll send that over to basically everybody. All right. There's that one for you. Has anyone got any questions? How about you, Valavan? Did you want to hang around, mate, and have a bit of a chat and me explain some of this to you, or is it going to be more beneficial for me to send you over some exercises and you just have a go at them and then send them back to me?
Yeah, if possible, I can talk to you, Adam, and
Yep.
if you have time.
Yeah, that's sure, mate. Yeah, we may as well do it now. I don't think any other guys have got any other questions. So by all means, mate, we'll just spend as much time as you need now to go over it.
Okay. the first one that we did, and to be honest, regarding it, I didn't understand much about it, and
That's okay.
lack of this technical side. If you can help me to understand that and the questions.
Yeah, mate. I'll bring this one up for you. So just make sure. So this one here. Sorry, I'll make this so you can see it. So this one here.
Yep.
Yeah. Okay. All right. So this one here is a. And one second, I'll grab my Australian Standard. So I'm reading off my hard copy as well. So this is a stiffened raft slab. So the way that we would know this is a stiffened raft slab is basically by, the way that I know it, is by these 45-degree angles, basically where it's got our beams into the ground, and then, well, basically our beams down here, and then on the top, and that's at a 45 degrees. So we know that's a stiffened raft slab. So therefore, when we need to fill in this detail, we would just go to our Australian Standard and look for stiffened raft, and that is on page number 30. So let me bring it up and I'll put it on page 30. So that you can see that there is pretty much the same drawing. So what doesn't change is really the width of these edge beams here, the width of our internal edge beams, and then this distance in here when it comes down on the 45. So horizontally, that's basically your 50 millimeters, and then our slab thickening, because that would be a load-bearing wall. And so if we've got a load-bearing wall, we need to make that slab a little bit thicker, because otherwise it's only 100 millimeters thick. So we make that an extra 50 mil with some extra mesh in there, and then that will then support that load-bearing wall, and the slab isn't going to want to crack. And then this other load-bearing wall, it's showing us that we can actually have a load-bearing wall within a metre of an internal beam, and then we don't need the slab thickening. So that's just showing you the two scenarios for if we've got load-bearing walls. And the only stuff that... Sorry, what was that, mate?
Is it slab thickening? Is it always 50 millimeter or?
Yeah, exactly, yeah. Yep, so it's always basically, we're in total 150 mil, so normally 100 mil, and then that 50 millimeters. Yeah, and when it's always 150, you've got to remember to like this is the minimum requirements. So you might find that someone, to be safe, might make it 160, but as per the standard, it's just got to be a minimum of 150.
Oh, okay. Yep.
And so, so then the only things I said that change is really, I suppose, like the depth of the footing, and that's when we come over and use this table here, where you just go, what's my site classification, and then what type of construction am I using, and that'll then give you the depth, which gives that one there, and then the reinforcing as well. So you just go to the table, and that's when you have a look at the reinforcing, and it tells you that the bottom reinforcing, you can either use that trench mesh, or if you want to use bars, that's the alternative if you want to use the bars. So the bars are just like a round, rod of steel, they'll be 6 meters long, and that one there would be 12 millimeters thick. And so this one, some of them you'll need like top reinforcing.
Is it 2 and 12 means 12 millimeter thickness of 2 bars?
12 millimeter.
Yep,
yeah, so, so when you have a look
of
on here, there'll be somewhere where it talks about basically what the different, actually that thing I sent you over tonight will give you what those different meshes mean. So when it talks about bars, talks about your square mesh and your trench mesh, that'll be listed in that document I sent over to you before. So when you look at that and you go, geez, what's 311 TM or what's 2N12, then you'll be able to look at that document I sent and it'll give you what those are. And you'll see some of them too, then we've actually got to put basically top reinforcing as well. So that's what that, some of them don't need it, but some of them do need it. And then this column was then when we spoke about with our beam spacing. So let's see if I can, hang on a second, mate. Let's see if I can bring up the answers. So this is not for this exercise, this is for a different one. But when we spoke about our beam spacing, which it shows us on there, basically to get that, that's when we look down here. So just remember the first one's 4 meters in, and then after that Then it talks about after the first one in from the corner, what spacing can those beams be?
Okay, yeah.
Yeah, so what
So
I'll do...
after 4 meters, the board is 6 meters.
Yeah, exactly. So I'll bring it down here, and just let me find the page that it's on. So on page
And
number...
I sent a question.
Sorry, what was that?
About that as well.
Yep.
I sent a question about that as well. And say if you're saying like a 4 meter from the first one,
yep,
and two sides, right? So say if it is a rectangular side, and either that side or this side, and where do you start, and how do you identify like a way to start?
Yeah, okay. So let me, I'll bring up this picture.
Yeah.
Oh, hang on, it's not on any of those. I've got that many things open. It's so hard to, I need about 5 screens.
Oh, sorry.
Here we go. Yeah, so basically what you would do, because when we look at it, actually I'll show you the two to try and understand it a bit better. So when we look at our Australian standard, and it's on page, I've gone too far, 52. 1 second, mate, let's get back there. All right, so we're doing it here. So it just shows us that from, if we read this, it says where the raft design includes internal beams, so it's going to have internal beams, all external corners, the maximum distance between the corner and the intersection of the first internal beam shall be 4 meters. So it's basically showing us, but we start from the outside. So if we were doing this other one here, I'll put the answers up so we can see it. So if we're doing this one here, let's make that fractionally smaller. So what you always do is come in your 4 meters. I've done this a little bit differently because from reading a bit further on, we know that if there's an internal corner like that, it has to go all the way through. So, but what you would, and I've just made it in the middle because the distance from here to here is bigger than 4 meters, we've got to put one through the middle. So I've worded that wrongly. Because that's bigger than 5.8 meters is bigger than 4 meters, so we've got to have a beam through here somewhere, but it can't be any more than 4 meters away. So they've just put it in the middle.
Yep.
Because this one here has got to go all the way through. But if those measurements were totally different, the first thing you would do is just make sure the first one came in was basically no further than 4 meters. And so you just come in, you go 4 meters, you do that from basically both sides, and it just turns out that they only need one in the middle. And you do that from all the corners, come in 4 meters to get that one, come in 4 meters to get that one, come in 4 meters to get that one, and then you would then break up the rest of the measurements to either your 5 or your 6 meters or basically whatever it had to be. So you just always come in 4 meters from the corners, because you can see that's what I've done here. Yeah, so on this one here, they've come in 4 meters and then gone 3.2 and then 4. Whereas this one here, they've just gone 3.8 because they knew they needed 3 of them. Sorry, 2 internal ones. They've just made it even spacing. So as long as you're not, basically going above that, you always start from your corners is what I'm trying to get out. Because you do your corners and then you work your way in from there.
Oh, yes, yep.
So yeah, hopefully that makes sense. It's hard when I can't actually, if I had a whiteboard here, I'd be able to draw it up for you. But yeah, if you can basically just follow these rules here, I got it. Do your 4 meters like that, and that's then you just basically work out the rest after that.
Got it. Yeah, got it.
All right, cool.
I thought like only one side got to be the start side got to be the 4 meter, but actually all the corners got to be 4 meters.
Exactly. Yeah, so in every direction from the corner, 4 meters. Yeah, so just like that. Yeah, cool. And what I'll do, I'll send you over like that one. I've got the answers for. It's a little bit tougher. Oh, it's not tougher, just because the mathematics makes you think about it a bit more. But I'll somehow work out to get the answers out of there. I might even it's just easy for me to white it out. I might even white it out and send you over a blank one and then send you the answer. So then you guys can have a go at it and then check it against the answers to see how it ended up.
That'll be really good. Yeah.
Yeah, cool. Yeah, so with that, I just think it probably won't be until probably Thursday or Friday, but I'll definitely get it done before the weekend.
Thanks a lot. Thanks, Adam.
Cool. Did you want me to cover any of the other ones with you, or you're good with that?
The other one as well, please. Yeah.
Yeah. So so then, where's the questions I was doing? So this one here was just the same thing. It's just a waffle pod. And it's really the same as what we did there. We just go to our Australian standard and we go to the waffle raft section.
Yeah.
Which is, I'm getting there. Our waffle raft's the same thing again. It basically just gives us a lot of our standard measurements, and saying this one here, it's only 85 millimeters thick, and basically the space in between there is 110. And when you basically you then look at this here, and it gives you the variables. Okay, so what's the depth of my beam, and then what is the bars that I can use, and then also talks about your internal beam. What mesh or what bars go in here. So when you have a read through this, it'll give you a little bit more definition around that, but it's pretty much the stem width. So that's this part here. So like their internal beam on this, you'll see here they've got basically they call that their stem width there on that little part there on the side. And it talks about, basically how big that's got to be in relation to what type of cladding you've got on the outside.
Yep, got it. Yep.
So if you ever read through that, it'll make sense to you. And then, yeah, cool. No worries, Tom. Oh, yeah, next Tuesday being a public holiday, I'll have to find out about that. Whether they want to run it or not. I'm happy to do it if you guys are going to be here. I won't be doing anything. So I might be like a zombie because I actually go to the dawn service on on Tuesdays. So yeah, but that's all right. Yeah, if they're happy for me to run it, guys, I'm happy to do it, and I'll just check with them. Yeah, no. Well, the worst part is, Tom, is that I actually did my trade in the army, and yeah, so Anzac Day is normally a pretty big day where we get up about 4 o'clock in the morning, and we used to start drinking at about 6 o'clock with our breakfast. So, but now that I'm not at the army base I served, it's really just the dawn service. So I should be all right. I should be tough enough to do it. So yeah, so back with this other one, then I'll show you the strip footing then, and we'll just cover that one. So yeah, this strip footing. And once you can sort of understand one of them, Valavan, the others sort of just follow
pretty similar.
Exactly. So this one's Australian, and if I bring up the Australian standard, it's really just, what's page is a strip footing on? Give me a second. Page 37. So strip footing is really just the same. You come down, you basically get your soil classification, and yeah, basically what's the depth, what's the width, and what's my reinforcing. So the only thing that changes a little bit is then with these internals, what have you got in there? Have you got basically, your pad, or have you got your stump, or whatever it's going to be. So that's how it varies a little bit on it, but it's really just getting the information out of that table. And when we draw these up, it gives us that they're 6 meters maximums, and basically they've got to go through from one side to the other, and that describes in here when we're talking about on deep beams. Sorry, I've gone past it. Must be on this part here. So you'll read through there, and that'll just basically tell you they can't be any more than 600 centers, and they've got to go from one side to the other.
Yep, got it.
So yeah.
And the only thing I'm confusing about this and the measurement of DF versus DS.
Yeah, okay. Yeah, and I explained that badly before when I did it. So DF is basically, because that's your external, so it's more than likely going to have an external load-bearing wall on it. So it's going to be for, you can see how much concrete is in there. So it's for your strip footing, where the concrete, where the where the brickwork sits on, whereas your DS is actually if you've got a stump in there. So it's got to do when it says the stump pad size. So basically the hole in the ground that we put in there to put our stump in there. So that's why it's different, because as you can see, and we'll cover this in our next session, you've only, in normal terms, to be honest with you, whenever I've done this, we've always put the concrete to the top anyway. But if you read the Australian standards, you've only got to put about 200 or 300 millimeters of concrete in there, but you've still got to have that deep enough with the soil around it. So yeah, the DS is basically if you've got a stump in there, it's going to be a different sized hole to if you've got an actual footing with reinforcing in it.
Okay, yeah.
Yeah, so see that one's a stump.
So in terms of height, it's going to be pretty much similar, isn't it?
Well, if we have a look, not always. It does look that way in the actual picture there, but when we look at it here, basically the further we start to get into Let's have a look. Yeah, if you have a look, that they are similar but not exact. So if you look on here on a Class M, the depth of that strip footing is 900 millimeters, but when you do the stump, it's only 500. But then on this one here, they're exactly the same. They're 1100 and they're 1101 meter. So yeah, basically, so this column here is for your basically the depth of where your stump's going to be, and this one here is the actual depth of the external footing, basically where that brickwork's going to be sitting on.
Yep. That makes sense.
And it is confusing. That was one thing that whilst I understood it, the first time I trained it, I struggled to think, how am I going to teach this to guys? But yeah, that's, see, and you can see here too that that's obviously then the reason why it's probably going to be less is because of the cladding on it, because it actually doesn't have brickwork. It's probably just going to have some weatherboard or something down the outside as well. Whereas this one here has got, you know, those 2 rows of brickwork on it.
Brickwork on it, yeah.
Yeah.
Got it.
Well, I'll sort these out and I'll send something over before the weekend, and see how you go.
Yeah,
if you've got any questions, just send me an email and we can have a chat about it too if you like. So yeah, if we need to talk about it, just know, and you got my number from the email, and just give me a ring.
Yeah, sure. Thanks a lot, Dan.
All right, cool, mate. All right, guys, I'll find out what we're doing next Tuesday, and if we're on, you'll basically get the invite. Cool. I'll speak to you then.
Thank you. Thanks.
See you later, guys.